Hello, everyone, and welcome. Today, we're going to build your essential probability toolkit. Think of these as the foundational skills you absolutely need to make smart investment decisions when you can't be sure what the future holds. This is crucial for your CFA Level 1 exam, and even more so for your career. So let's jump right in. So this is the big question, right? The entire market is built on possibilities, not guarantees. So how do we go from just a hunch about the future to actual hard numbers that we can plug into our models? Well, the answer lies in understanding the language of probability. Okay, our first and maybe most important tool is the expected value. I want you to think of this as your single best guess. When you're looking at an investment that has a whole range of possible outcomes, the expected value is your anchor, your central point of reference. Now, an expected value isn't just any old average. It's a weighted average. And that's a really key distinction. It's smarter because it gives more weight, more importance to the outcomes that are more likely to actually happen. It's the most likely average result you'd see if you could run the scenario over and over again. And here's the formula for it. Now, I know formulas can look a little intimidating sometimes, but the idea here is actually really simple. All this is saying is, for every single possible outcome, we'll call it X, you just multiply it by its chance of happening, which is P of X. Then you just add up all those little pieces. That's it. Let's make this concrete with a real-world example. Say we're looking at a company called Ron Stores, and we're trying to forecast its earnings per share. Our analysis shows there's a 10% chance the EPS will be 180, a 40% chance it'll be 120, and so on. So with all these possibilities floating around, what's our single best estimate? We just use our formula. We take each possible EPS, multiply it by its probability, and then sum it all up. So that's 10% times £1.80 plus 20% times £1.60, all the way down, which gives us one single probability-weighted forecast, £1.28. This now becomes our baseline for analysis. Okay, so we've got our expected EPS of £1.28, but that number doesn't tell the whole story, does it? How confident should we be in that number? Are the other possible outcomes clustered really tightly around it, or are they spread way out? This is where risk comes in, and our next tool for measuring it is variance. To put it simply, variance is a number that represents uncertainty. A small variance tells you that the actual outcome is probably going to be pretty close to your forecast, which feels good. But a large variance, well, that's a red flag for high volatility and risk. It's telling you not to get too attached to that single expected value. Now, calculating variance looks a bit involved, but it's really just a logical four-step recipe. First, you figure out how far each possible outcome is from your expected value. Then, you square those differences. This just makes all the numbers positive. After that, you weight each of those squared differences by its probability. And finally, you just add it all together. Let's see this in action with stock A. This table lays out the whole process. So after we figure out the expected return is 13%, we look at that fifth column. That's the deviation. It's how far each outcome is from our 13% average. Then we square them. And in the final column, we multiply each one by its probability before adding them all up at the bottom. And that sum gives us a variance of 0.00280. You might be looking at that number and thinking, what does that even mean? And that's a fair question. It's not very intuitive. That's exactly why we often take its square root to get the standard deviation. It just brings our risk measure back into the same units as our data, in this case, percentage, which makes it so much easier to understand and compare. You know, very few things in finance happen in one simple step. Usually one event leads to another, which leads to another. To handle that kind of complexity, we need a visual tool. So let's add the probability tree to our toolkit. A probability tree is just a fantastic way to map out events that happen in a sequence. So in this case, the first event, or the first set of branches, is the state of the economy. We've got a 60% chance it's good, 40% chance it's poor. Then, depending on which of those paths we go down, the company can have good or poor results. To get the final probability of one complete path, you just multiply the probabilities along the branches. It makes a complicated situation really clear and easy to see. And hey, this should look familiar. Once the tree gives us the final probabilities for each of the four possible scenarios, we can calculate the overall expected EPS, just like we did before. We multiply each outcome by its combined probability, add them all up, and we get our final expected value, $1.51. All right, on to our final and you could argue most powerful tool. The world isn't static. Information is always changing. Bayes' formula is our systematic method for updating our beliefs, our probabilities, as new information comes to light. It's all about adapting. Let's set up a scenario. We start out believing there's a 60% chance the economy is going to outperform. We also have some ideas about how a stock will behave given the economy. For example, if the economy outperforms, we think there's a 70% chance the stock will go up. Now here's the crucial question. We get some new information. The stock went up. Does this new fact change our original 60% belief about the economy? Intuitively, yeah, it should. A rising stock seems like pretty good evidence the economy's doing well. But by how much exactly? This is where Bayes' formula comes in. It's the engine that performs this calculation for us. It lets us take our initial belief, what we call our prior probability, and combine it with this new evidence to create an updated, more informed probability. And here's the payoff. From our probability tree, we know the chance of both the economy outperforming and the stock going up was 42%. The total probability of the stock going up no matter what the economy did was 50%. So our updated probability is that 42% divided by the total 50%, which is 84%. Think about that. Our belief that the economy is outperforming literally jumped from 60% all the way to 84% just based on one new piece of data. That is incredibly powerful. All right, that was a lot, so let's do a really quick recap of the core tools we've just covered. These are absolutely fundamental, not just for the exam, but for thinking like a real analyst. So first up, expected value. That's your single best guess. Second, variance. That's how you measure the risk or uncertainty around that guess. Third, a probability tree, your go-to for mapping out complex, multi-stage scenarios. And finally, Bayes' formula. That's how you intelligently update your views when you learn something new. So there you have it, your foundational toolkit for thinking about an uncertain future. But remember, these aren't just formulas to memorize, they're practical tools for making better, more informed decisions. The real question now is, how will you start using them to challenge your assumptions and build stronger, more resilient investment ideas?
我是 T 纽约，